Alright team, it's lesson 2. In this lesson we're going to be trying to, it's lesson 2. In this lesson we're going to be trying to be using Cosec and Cosec. Nothing too crazy, but you should make sure that you've looked at lesson 1 before you start lesson 2. So when you are using these things, the main aim generally is going to be to try to get things to have sine of x or cos of x involved, and if you really need it, tan of x. These two are going to be the ones you most often use, because when you're simplifying stuff, you should know that if you had that equals 1, doesn't it? And so that really does simplify some stuff. So on question A here, we've got sine of theta. Well, sine of theta is just sine of theta. We're going to multiply that by cot theta. Now it's no good giving that as 1 over tan theta. There'll be no point. Try to get sine version of it. Now C-O-T, cos on top, and so that's going to be cos theta over sine of theta, and sec is going to be 1 over, third letter rule, it's a C, so that one's going to be cos theta. When we multiply those things together, you'll end up with sine theta cos theta over sine theta cos theta, which comes out as 1. Okay, nice and simple. With question B, sine theta cos theta are just exactly what you'd expect, but you've got sec, which is 1 over cos theta, plus cosec, which is 1 over sine theta. That'll be sine theta cos theta multiplied by cos theta first. So sine theta cos theta multiplied by cos theta, these two things will cancel, and then you've got sine theta cos theta multiplied by 1 over sine theta, which will come out as just cos theta, and that one's simpler again. Don't try to think that you can just square this and it can end up looking like that. It won't. If you square this, you'll end up with sine squared theta plus cos squared theta plus 2 sine theta cos theta. So it's not exactly the same, so you shouldn't be trying to square it, and it won't really help you out with this. Next, prove this stuff. Now, really often what you get in when you're using these further trig is you get in kind of 1/overs, or you get in fractions, and in this case what's going to happen is you're going to end up with a fraction over another fraction. Now, it's always a good idea anyway to deal with the numerator and then the denominator separately. But with this, you'll see that it would be really difficult not to do it that way. So my advice would always be to tidy up the numerator as much as you can, tidy up the denominator as much as you can, and then consider the division later. And that'll be pretty much the same for any question that looks like this. So first off, part A, in the numerator, you've got cot theta, which is cos on top. That is cos theta over sine theta, multiplied by cosec theta, which is going to be 1 over sine theta, which comes out as cos theta over sine squared theta. That's the numerator. Now in the denominator, you're going to have sec squared theta, which is 1 over third letter, which is cos squared theta, plus cosec squared theta, which is 1 over sine squared theta. And when you do that, you're going to multiply that by that, and then add those two, multiply those two things together. So you'll end up with sine squared theta plus cos squared theta over cos squared theta sine squared theta. And obviously look, the numerator there, that's 1. So 1 over cos squared theta sine squared theta. So the numerator is going to be divided by the denominator. We could think of that as being the numerator multiplied by the reciprocal of the denominator. That's what I'm going to do. Makes things easy. So we've got cos theta over sine squared theta multiplied by, flip that one upside down, and you'll end up with cos squared theta sine squared theta over 1. Now, this and this will cancel. This is just a 1 and it'll be multiplied by a 1. But also cos theta multiplied by cos squared theta is going to be cos cubed theta, as we expected. There it was. That was what we were after. So we've done it. Good news. Now for B, hence, means we're probably going to use what we've just done, and look at it. This, check, always check, is this the same as this? Not just does it look roughly like it, it's got to be exactly the same if you're going to do what I'm going to be doing. So this is the same as this, and so therefore cos cubed theta must be equal to 8 in this case. So we've got cos cubed theta equals 8. And we need to explain why that's got no solutions. Well, that means that cos theta must be, well, cube root this, and you end up with 2. Okay, well, cos theta equals 2. Is there a value of theta that you can plug in that will give out 2? Well, no, there's not, because the maximum for cos theta will be 1. So the max of cos theta is equal to 1. As 2 is greater than 1, cos theta cannot equal 2, or no solutions exist. You have to give that explanation though. Look, it says explain it, so do the explanation. Don't just make me figure it out. Don't give me that and then tell me to figure it out after that. It's your job. Okay, next up. These can be a little bit more tricky than you'd think. I actually made a mistake on these while I was doing the kind of first go at this video. So we've got 1 over cos theta is equal to negative 2.5. That's okay. That means 1 over negative 2.5 is equal to cos theta. Okay, you can move that and that, you can swap those things around. We should know that's absolutely fine. If you think of 10 over 2 is equal to 5, well, also 10 over 5 is equal to 2. Those two things can swap. That's okay, it's not a problem. Now, 1 over negative 2.5 is going to be negative 0.4, so you're going to get cos of theta is equal to negative 0.4. Don't get too confused with this. We're going to just use theta is equal to cos to negative 1, the inverse of cos applied to negative 0.4. That is not the same as sec. It's not the same as sec. It's cos to the negative 1. It's inverse cos. It's shift on your calculator, cos negative 0.4. Now, you'll get from that theta is equal to 113.58 degrees, but you can cast it as well. So you've got C, A, S, T. Have a look at where we go, and we're going between 0 and 360. So I'm not going back, I'm just going forwards. I'm going into the nice 4 quadrants that we usually like. And so I've got here, look, 113.58. Work out that gap there. Okay, well, that gap there will be 180 minus 113.58. Whoops, 113.58, which is 66.42. So this thing here is 66.42. Where else is cos negative? Look, cos is negative in this case, so it's negative there, it's also negative there. Okay, and that'll be 180 plus 66.42. 180 plus 66.42 will be 246.42, and those will be your values. Okay, it'll occur twice in there. Now with B, you need to be much more careful. Look carefully. The input has been doubled, and then you've got cot applied to it, and that equals 0.6. So if cot of 2 theta is equal to 0.6, well, that's 1 over tan of 2 theta that equals 0.6. Now that tells me that 1 over 0.6 must equal tan of 2 theta, which also tells me that tan to the negative 1 of 1 over 0.6 inverse tan of 0.6, 1 over 0.6 will equal 2 theta, and that's absolutely critical. You should not try to divide too early. And I'll tell you exactly when people start dividing and getting things wrong here. So we've got shift tan to the negative 1, and we've got 1 divided by 0.6, comes out as 59.04. Okay, so 2 theta is equal to 59.04 degrees. Okay, now where people go wrong with this, they'll try to divide this first and then cast. So they'll divide this, they'll get 29 odd, and then they'll try to cast after. It's the wrong way to do things. Okay, you need to cast first and then divide later, because what's going to happen when you cast is you're going to find every possible value on the wave, and then you're undoing the kind of squeeze or the stretch that's going on with this thing after. Okay, you'll find legitimate values, otherwise your values aren't going to be evenly spaced when you'd normally expect them to be. So let's cast this then. So we've got C, A, S and T. Well, this one here is 59.04, and so here 180 plus 59.04 is going to be 239.04 degrees. Not only that though, because this is a 2 theta, our domain, you could consider it to go from 0 to 720. You see, if I use theta, I can double everything and I'll get up to 720. So it's not just one loop around with this, it's 2 loops around. So there's going to be another whole loop here, which is going to be 360 plus each of those values, which is going to be 419.04, 419.04. Again, this is part of this. Okay, these are all part of the 2 theta thing, and you're going to end up with 599.04 degrees. After that, then you can divide. The very last thing you should do is affect this thing. Okay, if the function's been applied after the 2, which it has, you've got theta, you've doubled it, and then applied cot to it, it should be that you undo the function, which is what all this stuff is, and then after that, then you do your division. Okay, so each of those things needs dividing by 2. So you've got 59.04 divided by 2, which comes out as 29.52. You've got 239.04 divided by 2, which comes out as 119.52. 119.52. And you'll probably spot, look, the gap between these is 180 every single time, so you could just add on 90 each time, I think. Just watch out for stuff like that. Don't always try to lean on things like that, because it works really nicely with tan, but it doesn't work with the others. So 419.04 divided by 2, that's going to be 209.52, and 599.04 divided by 2 comes out as 299.52. 299.52 degrees, 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 and degrees. Okay, that one's done. Next up, write down the values of cot x. This is a weird question. This one wasn't one of the examples, but I think it's really important that you actually see it. So with stuff like this, with cot, you're expecting to produce cos on top of sine. Now, there are a few ways to think about this. The first one, though, most obvious thing is to obviously bring that sine underneath and bring that 4 underneath there. It's not overly complicated, this stuff. But when you're asked for the value of cot x, don't actually end up working out like some decimal value. Just get cot x equals. Okay, don't mess around with it. You'll be absolutely fine. Now, with this one, you're going to end up with 5 over 4 is equal to cos of x over sine of x, and so therefore cot of x is equal to 5 over 4. You can give it as 1.25 if you really like. For b, you've got tan of x is equal to negative 2. Now, cot of x is equal to 1 over tan of x. And in this case, if tan of x is equal to negative 2, then cot of x is equal to negative 1/2. Excuse me. And for c, we've got sine and cos. The inclination here, you might find that once you multiply everything up, leave the 3 on its own, and you'll end up with cos squared x over sine squared x. Okay, this thing multiplying by this thing, and this thing multiplying by this thing, which isn't complicated. That's standard stuff, and you should be able to figure that out. But you might be trying to produce some sort of like 1 minus cos squared x equals sine squared x stuff. Don't do that. If you give me 3 equals cos of x over sine of x, all squared, which is true. You know, that there, by the way, is exactly the same as that. You should know that from year 1. Well, that's going to be 3 equals cot of x, all squared. And so therefore root 3 is equal to cot of x. Is that finished? I don't think it is. Plus or minus. Okay? Make sure you get that thing on there. So your jobs, make sure that you take pictures of it. Make sure that they're neat. Chuck them on Google Classroom for me, and I'll try to have a little look at them and let you know how you're getting on. You can get in touch if you've got any questions. So those are the questions that I want you to do. Take a screenshot of them, crack on with them. You should be absolutely fine. Good luck.